Welcome to the deep dive. Our mission really is to take these incredibly complex shifts in tech, the ones changing everything, and just break them down so they're clear, so they're actionable.
Hmm.
And today, wow, we're tackling the evolution of artificial intelligence. It's a journey that technically spans, 60 years? But it feels like the biggest leaps just happened.
Absolutely. And to help us navigate this, we're thinking of it like the AI relay race. It's a good metaphor, I think.
Oh, I like that. A relay race.
Yeah, because every big breakthrough, every time the core thinking shifted, it's like a baton being passed.
Yeah.
And it's fast, often unpredictable, and totally transformative.
That really captures it, that sense of constant forward motion, maybe even chaos sometimes, where, what was cutting edge yesterday is, well, it's history today.
Exactly. And for you listening, getting a grip on this journey isn't just academic. It's actually key to really mastering AI as it stands right now.
Right. Because if you miss how we got from, say, simple rules to AI that can actually do things on its own.
Then you'll misunderstand the tools you have now. You won't grasp their real power or, frankly, their limitations.
So our goal today is to provide that context, right? To chart that path through all the twists and turns so you can see how we arrived at this point of, well, increasing autonomy.
That's the plan. A clear path through the complexity.
Okay, so let's map it out. You mentioned this relay race. We're looking at about 5 major legs or waves, starting way back, 1966. ELIZA, the original chatbot.
That's the starting line. Then came the expert systems era in the 80s. Big promises then.
Yeah.
Well, a bit of a collapse.
Okay, the first baton pass. Followed by a totally different approach, right? Statistical machine learning in the 2000s, learning from data.
Which then got supercharged by the deep learning revolution in the 2010s. Think image recognition AlphaGo.
Right, perception really took off. And that brings us to now, the 2020s. This is the era of transformers, large language models, LLMs, and what you're calling AI agents.
The current leg of the race, yeah,
Huh.
where AI starts to act independently.
Okay, that's a huge amount of ground to cover. So let's get started. Wave 1. So the starting gunfires. 1966. MIT, Joseph Weizenbaum creates ELIZA. You called it the first chatbot, but it sounds incredibly basic compared to what we have now.
Oh, it was. Fundamentally simple. ELIZA wasn't intelligent. It was a clever bit of programming designed to mimic a Rogerian psychotherapist, the kind who mostly reflects things back at you.
So it wasn't actually understanding what people typed.
Not at all. It used pattern matching. It looked for keywords and specific sentence structures. So if you typed, "I'm feeling sad about my mother," it might pick up mother and respond with something generic like, "Tell me more about your family."
Just simple rules and substitutions.
Exactly. He was looking for grammatical patterns.
Okay.
But here's the truly wild part, and something Weizenbaum himself was apparently quite alarmed by: the reaction.
People were blown away.
Astonished, utterly. Even though Weizenbaum tried to explain how simple it was, people projected genuine understanding onto it. They felt it got them.
Wow, so they wanted privacy with it, like talking to a real therapist?
Yes. His own secretary, who knew it was just a program, apparently asked him to leave the room so she could have her session in private. She genuinely believed it understood her, initially.
That's incredible. It says so much about us, about humans, doesn't it? Our readiness to see intelligence or connection, even in a simple reflection.
It really does. It showed that the initial hook of conversational AI wasn't sophisticated code. It was tapping into a deep human need. ELIZA was basically like a psychological mirror.
Okay, so that early, almost shocking success helps launch this first big phase of AI thinking. Symbolic AI, the era of rules.
That's right. The core idea was logic. If X happens, then do Y. The dominant philosophy for, well, quite a while.
And the thinking was that human intelligence itself could be broken down into these explicit rules and symbols.
Precisely. That if we could just map out all the facts and rules experts use, we could codify intelligence. Write it all down, essentially.
Which led to the peak of this approach, expert systems in the 1980s. You said they had some success.
They did, yeah.
Yeah.
In very specific, narrow domains. Things where you could actually list out all the rules and possibilities.
Like what, for example?
Think complex configuration tasks, like configuring mainframe computers, or medical diagnosis for very specific, rare conditions based on a checklist of symptoms and lab results. If you could define the problem space completely, they worked.
They were like super-powered checklists.
Kind of, yeah. They could often apply the rules faster and more consistently than a human expert within that narrow frame.
But the dream was much bigger, wasn't it? Not just niche tasks, but replicating general human knowledge, common sense, Why did that part fail so dramatically? This led to the AI winter, right?
It did. And understanding this failure is absolutely critical to see why the next waves had to happen. The core problem was that these systems were fundamentally brittle,
Brittle, meaning?
meaning they shattered the moment they encountered something slightly outside their pre-programmed rules. They couldn't adapt. And the biggest hurdle, the one they just couldn't overcome, was common sense.
Ah, the stuff we just know without thinking about it. Gravity works, water is wet, you can't put an elephant in a matchbox.
Exactly. All that implicit background knowledge.
Yeah.
For a symbolic system to handle the real world, you'd need to manually code billions, maybe trillions, of rules about basic physics, social norms, object properties. It's impossible.
So if you ask an expert system something simple but outside its domain, like, I don't know, is it safe to juggle chainsaws?
It would just fail. It wouldn't have a rule for chainsaw juggling safety. A human knows instantly why that's a bad idea, drawing on general knowledge about tools, danger, physics. The symbolic AI had none of that general context.
Couldn't make an educated guess, it just stopped.
It just stopped. It couldn't reason beyond its explicit knowledge base. The sheer effort of trying to code every possible exception, every piece of common sense, was completely unsustainable. It just didn't scale.
So the whole approach, this idea of intelligence as just a big book of rules, it hit a massive wall.
A hard wall of real-world complexity. And that forced the field to pivot, to pass the baton to a fundamentally different way of thinking about intelligence, learning, not programming.
Okay, so symbolic AI hits the wall. This sets up a huge shift. We move from trying to tell the machine the rules to letting the machine learn the rules from data. Wave 2, the statistical turn, early 2000s.
Exactly. This is the dawn of modern machine learning. Instead of a human expert meticulously defining every feature of, say, a cat.
Whiskers, pointy ears, fur.
Right. Instead of coding all that symbolically, you just feed the algorithm millions of examples. Pictures labeled cat, pictures labeled not cat. And the machine uses statistics to figure out the patterns that correlate with the cat label.
That sounds much more flexible, much less brittle than the old way. It's adapting to what it sees.
It is. It's learning from experience, essentially. And this approach started powering things we began to take for granted online.
Like, what were the big wins for this statistical approach?
Well, think about early Google search getting much better. Moving beyond just matching keywords to trying to understand the intent behind your search. That was statistical ML.
Okay.
Robust spam filters in your email. That's a classic example. Early speech recognition systems that actually started to work, mostly, also driven by statistical learning. They weren't perfect, but they were useful. They made predictions based on probability.
But there was still a catch, right? A bottleneck related to the data itself.
Oh, absolutely. A huge one. The problem was the massive amount of human effort still needed for feature engineering.
Feature engineering, meaning?
A feature is basically a measurable characteristic of the data that the algorithm can use to learn.
Yeah.
In that era, humans had to figure out what the important features were and manually code them.
So for the cat example, someone still had to tell the system, pay attention to eye shape or measure the distance between the ears?
Precisely.
Yeah.
You weren't coding the final if-cat rule, but you were manually selecting and defining all the inputs the machine should consider. You were telling it what to look for.
So humans were still doing a lot of the heavy lifting, just one step removed from the old symbolic way.
That's a good way to put it. These statistical models needed enormous data sets, yes, but those data sets had to be meticulously labeled, cat not cat. And critically, the data needed this manual pre-processing, this feature engineering. It was slow, expensive, and it limited the complexity of problems that ML could really tackle.
Okay, which perfectly sets up the next baton pass. Wave 3, the 2010s. This is where the machines started doing the feature engineering themselves, the deep learning revolution.
Exactly. Deep learning cracked two major problems at once. First, the models got much more complex. We started using deep neural networks, which just means networks with many more layers of processing between the input and output. The deep refers to the depth of those layers.
New layers, more sophisticated processing.
Right. But the second piece, and this was absolutely crucial, was the hardware. We finally got the computing power we needed from GPUs, graphics processing units.
GPUs. Most people probably still think of them for, like, video games. Why are they so important for deep learning?
Well, think about what a GPU does for gaming. It renders millions of pixels on a screen simultaneously.
Yeah.
It's designed for massive parallel processing, doing lots of relatively simple calculations all at the same time.
Okay.
And training a deep neural network involves exactly that. tons and tons of simple matrix multiplications performed over and over again across the entire network. It's an inherently parallel task. CPUs, which are great for complex sequential tasks, just weren't suited for it in the same way.
So the hardware designed for graphics turned out to be the perfect engine for training these huge, deep networks.
The perfect fit. Suddenly we have the algorithms and the horsepower. And this combination, deep networks plus GPUs, allowed the models to learn the important features automatically. No more manual feature engineering.
So instead of a person telling it to look for pointy ears, the deep network, through its layers, figures out on its own that certain combinations of pixels usually mean cat ears.
Exactly. It learns the relevant representations directly from the raw data.
Yeah.
This was huge.
So the machine wasn't just crunching numbers based on human guidance anymore. It was actually starting to perceive the world. What kinds of capabilities did this unlock?
This is where we saw those breakthroughs in complex perception.
Right.
Really accurate image recognition, identifying objects in photos almost perfectly. Huge leaps in speech recognition and translation. And of course, beating humans at complex strategic games like Go with AlphaGo.
Right. Machines mastered seeing and hearing, in a sense.
To a remarkable degree, yes. But even with all that power, there was still a significant gap holding back truly general intelligence.
What was missing at the end of Wave 3?
The main limitation was flexible reasoning and understanding long-range context. Deep learning models were fantastic at recognizing patterns over short spans, identifying an object, predicting the next word or two in a sentence,
Okay.
but having a long, coherent conversation, understanding how ideas connect across a multi-page document, grasping complex dependencies in large data sets. That was still really, really hard. They struggled to maintain context over longer sequences.
They had great short-term memory for patterns, but poor long-term memory for meaning and connection.
That's a decent analogy, yes. They lacked the architectural ability to effectively track relationships across significant distances in the data, and that limitation set the stage for the next massive leap.
Okay, so deep learning mastered perception but struggled with long-term context and flexible reasoning. This brings us to maybe the most critical moment in the entire race, the one that really defines the AI we interact with daily now, 2017.
2017. And the paper you absolutely need to know. Attention is all you need. This wasn't just an improvement. It introduced a completely new architecture, the transformer, and it changed everything for sequence data.
Sequence data meaning text, speech, anything that unfolds over time.
Exactly. Before transformers, the main approach for handling sequences involved things like recurrent neural networks, RNNs, or LSTMs.
Right, I've heard of those. How did they work?
They tried to process the sequence step by step, word by word, basically. They maintained an internal memory state that got updated as they read along.
Kind of like reading a sentence one word at a time and trying to remember the beginning.
Sort of, yeah. But the big problem was that the memory was fundamentally short-term. By the time an RNN got to the end of a long paragraph, it had often effectively forgotten the precise details or nuances from the beginning. It struggled to connect things that were far apart.
Okay, the vanishing gradient problem, is that related?
That's part of it, yes. It made capturing those long-range dependencies really difficult. Like trying to understand the plot of a novel by only remembering the last page you read.
So how did the transformer architecture introduced in that 2017 paper solve this memory problem? What did attention do?
The core innovation was the self-attention mechanism. Instead of processing word by word linearly, attention allows the model to look at all the words in the input sequence simultaneously, in parallel.
All at once. How does that work?
Well, for every single word it's processing, the attention mechanism calculates attention scores, it asks, essentially. How relevant is every other word in this entire input sequence to understanding this specific word right here?
So it's constantly checking the relationships between all the pieces.
Exactly. If the model is looking at the word it late in a paragraph, the attention mechanism can directly attend back to, say, the report mentioned 2 paragraphs earlier that it refers to. It doesn't have to rely on a fading sequential memory. It can directly link related concepts, no matter how far apart they are.
That sounds incredibly powerful. It's like having a full map of the entire text available at every single point.
That's a great way to think about it. It creates a rich contextual understanding across the whole input instantly. It solved the long-range dependency problem that plagued RNNs.
And that ability to handle huge amounts of context in parallel, that's what enabled the next big step.
That was the key. Suddenly, machines could perform tasks that require deep contextual understanding, sophisticated reasoning, summarizing long documents accurately, answering complex questions, generating coherent long-form text. things that were impossible before.
And this transformer architecture became the foundation for, well, everything we see now, right? Large language models,
Yeah.
LLMs.
Precisely. Transformers are the engine inside models, like OpenAI's GPT series, Google's Gemini, Anthropic's Claude, Microsoft's Copilot, all the big names.
These are the systems that can chat, write, code, analyze. They seem almost like they understand language.
They represent Wave 4 reaching maturity. They leverage that deep contextual understanding learned from trillions of words of text data to simulate reasoning and generate knowledge in a way that feels incredibly flexible and human-like.
Okay. But you hinted earlier that the race didn't stop there. Even as LLMs were amazing us with their conversational abilities, the baton was already being passed again. That contextual reasoning power is now being turned into something more active.
Exactly. The LLM is like the incredibly powerful brain. But
Yeah.
Wave 5 is about giving that brain arms, legs, tools,
Yeah.
and the instructions to go out and do things in the world.
Wave 5, the agent era. So the big shift here is moving beyond just talking or analyzing, beyond the chat window,
Yeah.
to actually executing tasks.
That's the core idea. We're moving from AI as an assistant you constantly guide to AI demonstrating genuine autonomy. It's about systems that don't just, say, help you draft an email, but can actually manage an entire project based on an objective you give them.
Okay, so an AI agent isn't just an LLM, it's something more. How does it work if the LLM is the brain?
Right. Think of the agent as a system built around the LLM. It harnesses the LLM's reasoning power, but puts it inside a loop that allows it to plan, reason, and act.
Plan, reason, act. Let's break that down. If I give an agent a complex goal, like find the top 3 marketing strategies used by our competitors in the last quarter, how does that cycle play out?
Okay, so planning. The agent, using the LLM's intelligence, breaks that big goal down into smaller, manageable steps. Step 1, identify the key competitors. Step 2, search for their recent marketing campaigns or announcements. Step 3, analyze the findings. Step 4, summarize the top 3 strategies.
Makes sense. What about reasoning?
Reasoning is the ongoing monitoring and self-correction. The agent constantly evaluates. Is my plan working? Did step 2 actually find useful information? Oh, the search for competitor X failed. I need to adjust my plan. Maybe I should try searching their investor relations site instead. It adapts.
Okay, and then the crucial part, act. This is where it goes beyond just thinking.
This is the leap. Acting means interacting with the outside world, usually by using tools. The agent knows it can't just imagine the competitor data. It needs to, for instance, use a web browsing tool.
So it can call external software, like using an API.
Exactly. It uses function calling or API calls.
Yeah.
Might call a web search API, get the results back, parse the information, maybe call another tool to analyze sentiment in the text it found. It orchestrates these tools to gather information and achieve its sub-goals.
And it has to be able to figure out if the tool actually helped, right? It can't just blindly follow the plan.
Yeah. Crucially, yes. That self-critique and validation step is vital. Did the web search return relevant links? Did the analysis tool provide useful insights? If not, back to reasoning and maybe replanning. This loop is what gives it robustness and autonomy.
Wow. And you mentioned agent swarms. It gets even more complex.
Oh yeah. Agents don't have to work alone. For a really big task, like develop a full launch plan for our new product, a primary manager agent might break it down and delegate parts to specialized agents.
Like a team.
Kind of, yeah. A research agent could gather market data, a content agent could draft marketing copy, a finance agent could model costs, maybe a scheduling agent coordinates deadlines. They collaborate, passing information back and forth, coordinated by the main agent.
That's a whole different level. That's
Yeah.
not assistance anymore, that's delegation.
Precisely. That's the core insight of the agent era. We're shifting from assistance, where the human is always in the loop, prompting, refining, checking, to true AI autonomy, where the human sets the high-level objective and the agent system figures out how to achieve it, executing multiple steps, using tools, collaborating, and problem-solving along the way.
So if you, listening right now, are mostly using ChatGPT to help you write things or summarize text, you're still kind of operating in Wave 4 mode.
You're using a powerful tool, absolutely. But you're not yet leveraging the autonomous execution potential that defines Wave 5. The race is now being run by those figuring out how to delegate outcomes, not just tasks.
Okay, this shift from assistance to autonomy, it can sound a bit abstract. Let's make it concrete. You suggested using an example, Nadia, a business consultant. How would her actual day-to-day work change across these AI waves?
Yeah, I think following Nadia's journey really highlights how fundamental these changes are. Let's start back in Wave 2, the statistical learning era. Think 2005.
Okay, 2005, what's Nadia doing?
In 2005, Nadia is basically a human data cruncher and synthesizer. Her main AI tool is probably Google Search's statistical engine, remember? She spends countless hours finding reports, reading articles, manually pulling numbers into spreadsheets, maybe running some basic regressions.
So she is the one doing the feature engineering, finding the key data points.
Absolutely. She's identifying the important metrics, manually extracting growth rates, market shares, etc. The AI helps her find information, but the analysis, the synthesis, the real work, that's all her. She's the bottleneck in the process.
Okay. Now jump forward 10 years, 2015. Wave 3, deep learning, is in full swing. Perception gets good. How does Nadia's workflow change?
Her toolkit gets way better. She's not just using search. She now has access to pretty good voice transcription software. Hours of client interviews, transcribed instantly.
That saves a ton of time.
Huge amounts. She can use image recognition tools, perhaps, to analyze product placements in photos or track visual trends online. The AI is handling the perceptual data intake much better.
So less manual data logging, more automated input.
Right. Her ability to gather diverse data scales up dramatically. She's still the primary analyst and strategist, but the front-end data processing is becoming much more efficient thanks to deep learning's perceptual abilities. She moves from data cruncher to, maybe, perceptive analyzer.
Okay. Next stop, wave 4. Let's say 2020. Transformers have arrived. LLMs like GPT-3 are available. How does that change your game?
This is where AI starts to feel like a thinking partner. Nadia moves beyond just data analysis into actual strategic support. She can feed an LLM dozens of research papers and ask it to synthesize the key arguments or identify conflicting viewpoints.
Brainstorming partner.
Exactly. She can ask it to draft different strategic options based on her findings, or outline a complex client pitch deck in minutes tailored to specific needs. The LLM becomes a powerful assistant for ideation, summarization, and drafting.
But she's still driving, right? She's prompting, guiding, refining the output.
Completely. She's the conductor. Her expertise is essential to ask the right questions, evaluate the LLM's output, and make the final strategic calls. The speed and quality of her support tools have skyrocketed, but the workflow is still fundamentally human-led assistance.
Okay. And now, today, let's say 2025. Nadia embraces wave 5, the agent era. What does her workflow look like now?
It's almost unrecognizable compared to even 2020. She's not spending her days prompting an LLM or manually searching. She delegates the entire outcome.
How does that work in practice?
She might give an agent system a high-level objective. Produce a comprehensive competitive analysis comparing companies X, Y, and Z, focusing on their Q4 marketing strategies. Generate a 20-slide deck summarizing the findings, including key visuals. Oh, and schedule a meeting with the client for next Thursday afternoon to present it.
Wow. And the agent system just does all that.
That's the goal, yes. A swarm of agents might take over. One agent uses web browsing tools and financial data APIs to gather the raw intelligence. Another agent analyzes the competitor actions, maybe looking at ad spend or social media sentiment. A third agent drafts the presentation, potentially using another tool to generate charts. And a fourth agent interacts with a calendar API to find a slot and send the meeting invite.
So Nadia's role shifts completely again. She's not the doer, not even the prompter, really.
She becomes the strategic supervisor and the final validator. She defines the objective, oversees the process perhaps, checks the quality of the final output delivered by the agent system, and then adds her human expertise in the client presentation. The execution chain, however, is largely autonomous.
That is a profound shift. The lesson here for everyone listening, it's not just about getting faster at your current tasks using AI.
No, it's about fundamentally evolving your role. Nadia stayed relevant and effective because she adapted at each wave. She learned to stop just assisting the AI and started supervising its autonomy.
So the takeaway is, if you're still primarily focused on writing the perfect prompt,
You might be missing the bigger picture of Wave 5. Mastery now involves shifting from asking an AI for help with a task, Wave 4, to defining an outcome and delegating the entire mission to an AI system, Wave 5. It's a different mindset. #tag7, synthesis and conclusion.
what a journey. From ELIZA just mirroring words back in 1966, all the way to these autonomous agent swarms tackling complex projects today, it really underscores how fast the underlying idea of AI keeps changing. Let's try to boil this down. What are the absolute key takeaways for someone trying to master this landscape?
Okay, I think there are three essential points. First, AI evolves in these distinct waves, and each wave fundamentally solves a limitation of the previous one.
Right. Symbolic AI was brittle, couldn't handle common sense.
So statistical ML came along, learning from data, but that needed painful manual feature engineering.
Leading to deep learning, which automated perception but struggled with long context.
Until transformers arrived with attention, enabling LLMs. And now, LLMs alone are seen as assistants, not actors, leading to agents. Understanding that chain reaction constraint, solution, new constraint is key.
Okay, takeaway number 1. Each wave builds on and overcomes the limits of the last. What's number 2?
Number 2, we are now firmly in the agent era, and the defining characteristic is increasing autonomy. The focus is shifting, or should be shifting, from using AI as a static tool, like a calculator or a word processor, to deploying AI as a dynamic executor that can plan, reason, and act using tools to achieve goals.
It's about action, not just answers.
Precisely. And the third takeaway, which ties it all together for practical application. To really master AI today, you need to grasp the whole story.
You can't just jump in at wave 5 without understanding why we needed it.
Exactly. Knowing why rule-based systems failed helps you appreciate why data-driven learning was revolutionary. Understanding the limitations of early ML helps you see why deep learning was transformative. And recognizing the context gap that LLMs filled helps you understand why agents are the logical next step. That historical perspective lets you leverage today's tools, these autonomous agents, much more effectively. You'll know when to delegate, what kind of supervision is needed, and where the potential pitfalls are.
So you move from just being a user to being a truly informed strategist in how you deploy AI.
That's the goal. Be a supervisor of autonomy, not just a prompter of assistance.
We started this whole discussion with that metaphor, the AI relay race, tracking the baton from MIT labs 60 years ago to the massive cloud data centers running agents today. The speed has been just incredible.
Relentless. And the shifts haven't just been technical. They've been philosophical, architectural, fundamental changes in how we even conceive of building intelligence. And it feels like the acceleration is only increasing now.
We're leveraging that transformer power, not just for better chat, but for real-world action. Which brings us to our final thought, the one we want to leave you, the listener, with. We use the relay race metaphor.
Yeah.
Well, the baton has been passed again. It's effectively landed right here, right now, in the agent era. Metaphorically, it's in your hands.
So the challenge isn't just watching this race from the sidelines, amazed at the speed.
No. The challenge is to actually grab that baton and run with it. To consciously make that shift in your own thinking and workflow from directing every step to supervising autonomous execution. Because the pace of autonomy being set by this agent era, well, if you don't adapt, you risk getting left behind. It demands a new level of engagement, a new way of working with AI, not just using it.